Welcome at Alwaha International Language School, Prep 2. We're going to make a revision on Unit 2, Lesson 1 and 2. First, we're going to know what's meant by sound velocity. What's meant by sound velocity? It is the distance which is covered by the sound wave in 1 second. What's meant by sound velocity? It is the distance which is covered by the sound wave in 1 second. Number 2, what's meant by sound pitch? It is a property by which the ear can distinguish between rough and sharp voices. It's a property by which the ear can distinguish. Distinguish means differentiate between rough and sharp voices. Number 3, sound intensity. What's meant by sound intensity? It is a property by which the ear can distinguish between sounds. Either they are strong or weak. Again, sound intensity, it is a property by which the ear can distinguish or differentiate between sounds either strong or weak. Number 4, inverse square law of sounds. The inverse square law of sounds states that the intensity of sound at a point varies inversely with the square of the distance between that point and the sound source. It means that the intensity of sound is inversely proportional with the square of the distance. Okay? Number 5. What's meant by sound quality or type? Yeah, very good. It is a property by which the human ear can distinguish between different sounds. According to what? According to the nature of source, even if they are equal in intensity and pitch. Okay, move to the next one. Number 6. What the meaning of sonic waves? All of us know that we have 3 types of waves: ultrasonic, infrasonic, and sonic. The sonic waves, they are sound waves of frequency ranging from 20 to 20 kilohertz. Please take care, from 20 to 20 kilohertz. Number 7, what's the meaning of infrasonic waves? They are sound waves of frequency less than 20 hertz. So they are sound waves of frequency less than 20 hertz. And what about ultrasonic waves? They are sound waves of frequencies higher than 20 kilohertz. What the meaning of harmonic tones? What the meaning of harmonic tones? They are tones that accompany the basic tone, but they are lower in intensity and higher in pitch and differ from one instrument to another. Okay, let's move to the next question. Please take care. We are going to talk about give reason. Say why. Question number 1. Give reason for. We hear sound from all directions that surround the sound source. We hear sound from all directions that surround the sound source. Why? Because the sound travels through air as pulses of compressions and rarefactions. Very good. Whose center is the sound source? Again, why? Because the sound travels through air as pulses of compressions and rarefactions, whose center is the sound source. Let's move to the number 2. Question 2. Sound intensity increases when the sound source touches a resonance box. Why? Due to the increase of the surface area of the vibrating body. Very good. Due to the increase of the surface area of the vibrating body. Question 3. Sound intensity in case of the presence of carbon dioxide gas increases as the medium is higher than that of air. Again, sound intensity in case of the presence of carbon dioxide gas increases as the medium of carbon dioxide has higher intensity than that of air. Because the density of carbon dioxide gas is more than that of air. Because the density of carbon dioxide gas is more than that of air. And as all of us know, that as the intensity of sound is directly proportional to the density of the medium. As the density of the medium increases, sound intensity will increase. So in the case of carbon dioxide, as it has a high density, so sound intensity is strong. Number 4. The human ear distinguishes between sounds from different sources. The human ear distinguishes between sounds from different sources even if they are equal in intensity and pitch. How? Yes, excellent. Due to the harmonic tones that associate the fundamental tone of the source of sound and are lower in intensity and higher in pitch. Very good. Excellent. Number 5. Give reason. The human ear can hear sounds of frequencies ranging from 20 to 20 kilohertz. Because the ear transmits the effect of these waves to the brain, which translates them into sounds and edible tones. Edible mean sounds that can be heard. Again, number 5, it's a very important question. The human ear can hear sounds of frequencies ranging from 20 to 20 kilohertz. Because the ear transmits the effects of these waves to the brain, which translates them into sounds and edible or hear tones. Number 6. Some sound waves can't be heard. Some sound waves can't be heard. Why? Yeah? Let's answer it together. Because the frequencies of these waves are lower than 20 hertz or more than 20 kilohertz. So the human ear can't hear them as this. The effects of such waves can't be translated by the brain. Again this question. Some sound waves can't be heard because the frequencies of these waves are lower than 20 hertz or more than 20 kilohertz. So the human ear can't hear them as the effects of these waves can't be translated by the brain. Number 7. Dogs can hear all sounds produced by man. Why? Because man produces sound of frequency less than 20 kilohertz and dogs can hear sounds up to 50 kilohertz. Also the same for the dolphin. Man can't hear sounds produced by dolphins. Why? Because dolphins produce sounds up to 120 kilohertz, while man can hear only between the range of frequencies from 20 to 20 kilohertz only. Last question, number 9. When a sound ray is incident perpendicular to the reflecting surface, it reflects on itself. Why? Because the angle of incidence equal the angle of reflection equal 0. Thanks. Hope you understand it. See you again. Goodbye.